Soils are truly fascinating. They are not a solid, they are not a liquid, they are not a gas. Soils are granular materials. And between grains we have pores, and the pores are interconnected, and there are fluids. And sometimes there is more than one fluid: air, water, oil, contaminants, L Naples, D Naples. And there are mechanical effects, thermal effects, chemical effects, biological activity within the pores, and all this comes together to provide and create very unique properties to the soil mass. So these conversations started as a need to record classes to enhance and support our educational goals. And now we have a large number of videos that we have gradually recorded and we want to share with you. Throughout these videos, I'm going to emphasize simple concepts, very simple mathematics. The emphasis is on the physics. So sometimes I will invite you to feel like a grain, or even to feel like a water molecule or an ion in the soil mass. Please play the game with me, because if you do, you will really understand soil behavior in a new dimension. The scope has been organized into several playlists, but you can pretty much watch videos in the order that satisfies your current needs. At the beginning, there are some videos that will address the history of the Earth, but also the history of our community, and will highlight the laws of nature. We must not forget that there are very few laws, but we cannot violate them. Then we're going to look at soils, putting emphasis on the micro scale. The soil itself, as made of grains of different shapes and size, and the fluids. We will try to understand the unique properties, for example, of water, which is the prevailing fluid in our soil masses. And then we're going to bring the concepts of mechanics, and that will be theory of elasticity as well as frictional strength, to explore the mechanics of soils. There are a series of videos, that look at not at the grains, but at the pore structure created by the grains and the fluids within. These fluids can move at a steady state in what we call seepage, giving rise to the concept of permeability, but sometimes they can be squeezed like a sponge, and they get accelerated to gradually decay to a new asymptotic state, what we call consolidation or pressure diffusion. Now, in many cases, as we said earlier, the fluids are immiscible, and that is not completely true, because there is always some miscibility, but they have reached a point that they have saturated each other, and so we have oil and water, or air and water, and that gives rise to capillarity. So when we talk about immiscible fluids, we'll be really placing emphasis on unsaturated soil behavior. Now, there are new parts of soils that we need to understand, because in many of our applications, soils are subjected to a large number of repetitive loads. And I'm not referring here to liquefaction, which we will also discuss, but is the repetitive loading caused by the foundation of a wind turbine, which will experience millions of cycles, or the basis for a pavement, or beneath our driveways. And some of the loading will be both mechanical, but there will also be wet and dry cycles, freeze and thaw cycles, thermal cycles. We will see what is the impact of multi-physics loading on the response of soils. Now that I mentioned some of these other physical excitations, then we are going to refocus our attention on understanding the thermal behavior and properties of soils and some chemical issues. This gives rise to thermo-hydro-chemo mechanically coupled processes. And this is the reality that we face in a large number of applications. Case in point, for example, nuclear waste disposal. Then, in the very end, we have left a series of presentations and short videos to address other aspects that may be very relevant to you and also to the future of this theme, these topics, as we face new challenges, as we have seen the mechanics, geoenvironmental engineering, and now moving more into the climate effects and energy-related geotech. And so for that, there is a series of topics that we will fill in this section number 8, the playlist number 8. But I don't want to leave this scope without talking about the fact that there will be tendencies to localize, there will be spatial variabilities, bioactivity. It is very important in the coarse grain soils. And so we are going to explore some of these dimensions as well. I have to say that the videos have some mistakes, are incomplete, they are not clear enough. And what we have done is we have transcribed all the videos, we have edited them and completed them. Furthermore, if you look at the last slide of videos, we are listing primarily some of our own publications where we have covered some of these topics, but in the transcripts we're going to include key important references that you should explore as well. And all this is possible because Dr. Kjol Han is integral part of this effort, and we are doing all these recordings and all these transcripts and completions in collaboration with him. I am very grateful to him, and I'm very grateful to all the former students who have participated in this effort of understanding soils. It has been a fascinating experience. I hope you enjoy these conversations.